Hi, today we will see how to calculate mean and standard deviation for group data. A little bit different what are you doing for ungroup data. I continue with that example about samples of materials and strengths of materials was measured, and we discussed it previous week with you. And here are those 15 samples, and you remember from your previous math experience that to calculate mean, what we need to do, we have to add together all those numbers and divide by their amount. So this is the general formula for calculation of mean, and we got around 34.5. When we work in a statistic with group data, sometimes you even don't see anything like those data. Sometimes they are not known data. So sometimes we have just a group data, and we need to know how to calculate mean when data given in group data. The formula for calculation mean for group data, so what we need to do, we have to take midpoint for each class, multiply it by frequency for each class, add together by all those values, and divide by sum of frequencies of each class, and this is give you midpoint for group data. So let's continue this calculation. Let's set up this calculation. So we need to take midpoint multiplied by frequency, and we have to do it for each class. So midpoint here multiply by frequency, and because we have to repeat this calculation, I can just drag the formula. Okay, now this sign means total, the total. So let's calculate sum of those values. So I will use after sum, those values will be added. And to calculate mean, what we need to do, we have to total amount of frequencies, we have it's already 15 here. If you want, you can just you can use this one. So to calculate mean, this sum we divide by sum of frequencies. It's basically cumulative frequency, and we got our mean. So we calculated with UMean, and let's make it as a result of calculation. This is done. And now let's discuss how to calculate standard deviation, and a little bit later we will see what actually standard deviation mean. No, actually let's discuss what standard deviation mean, and after that let's calculate it. Somewhere here those are our data. Just little bit make clear what standard deviation is, what does it mean, for what we measure it, for what we calculate in it. Let's go to new. So standard deviation, it's a measurement how far our data spread from the mean. Sorry, where is my number one? Is this one, two? One data is disappeared. Never mind, I will just add it. I think it was 34.6 from the task. No, it's still white. It's still there. Sorry. Right, those are our data. I just won't go. I don't want to make mess here. So those are our data. So if we plot them on the graph, insert, and for example, this is our 15 samples, and each sample, sample number 1 represents strength of material, sample number 2, and so on. And we calculate it with you somewhere Somewhere we calculated with UMean, was around here. So what standard deviation mean? It shows us how far, it's a value which shows us how far data spread around the mean. Sometimes small standard deviation means that we have very good process. So for example, we create material and all material around the mean, and if your mean is a standard mean, so it's good that we don't have materials which is too strong or too weak. Okay. The letter sigma used for standard deviation, and they call it Six Sigma rule, that if we have mean, the smallest value always could be calculated in the sets of sample of materials is given by mean minus 3 sigmas, and the biggest value, it's a mean plus 3 sigmas. So these 6 sigmas give us spread of the material. In this example, it's material. Could be like, for example, average marks of students. So average marks, and someone got better, someone got worse. And 6 sigma give us all corridor for all results. And usually, if it's good process, so all data appears around the mean. Okay, let's see how to calculate the standard deviation. First of all, again, the formula for standard deviation you need to know, because here we have to just apply it. Sigma could be calculated. What people doing? So it's a spread around the mean, because some data spread it. Let's come back here. Some data, look, it's kind of average of those distances, but some distances are positive, some distances are negative. That's why we can't just add them together, because they could cancel each other. For example, this positive distance can, when we add together with negative distance, it will give us 0. But really, those two data spread it around the mean. They are not given 0. It's not a 0 distance for all 3 values around the mean. That's why what people do, when they calculate a standard deviation, from each data, they take away mean and they squared it. Why they squared it? Because we don't want this negative number. We would like all those numbers make positive numbers. But when we work with group data, we are using estimation of midpoints instead of each data. So from each class, from each midpoint for each class, we will take away the mean which we calculated, we will square it, and because we have to take into account frequency, we will multiply by frequency, because, for example, this midpoint in the sets of data appears much more times than this midpoint. That's why we always have to multiply it by frequency to take into account a number of times which data appears in the set. After that, we have to sum all of them. We will divide by sum of frequencies. And now we have to get rid of the square root. The square, we can take a square root of this. It doesn't give us just one average distance. That's why we're multiplying it by 3 to get whole spread. 3 sigmas up and 3 sigmas down. to get rid of this square. Alright, basically let's do it. Now, what we need to do, we have to calculate from each midpoint for each class. We will take away mean value and we will square that straight away here. Okay, so equal, where is midpoint? Midpoint is here. We take away mean. Where is mean? Is here. We squared it. That's it. Yes, that's what I want to do. Enter. So, you know what? Let's multiply it by frequency straight away, because we can whole numerator to do. So I will add here frequency time. So, and here we have to multiply it. Where is our frequency? Here, multiply. And this calculation we have to repeat for each midpoint. The only things, look, if I will drag it, it will be wrong. You know why? This is wrong just because our midpoint always in this set. So when I drag the formula, I will copy data for midpoints. I will copy data from here. For mean, it will be copied from there, but nothing in here. That's why if we would like to stack with this address of cell, hopefully you know that we are using the symbols of dollars to make absolute address of cell. So we always take data for midpoint from this Q, whatever is Q18 cell. Right, and now if I drag it, we will copy the data. So for example, midpoint for next class will be copied from here, but we still stuck with mean value on Q18 cell. Okay, so now we have to calculate total. So we add all those quantities together. And now we multiply by sum of frequencies. So basically we're calculating average those distances from mean and divide by 15. So this value is showing us a standard deviation. And sorry, it doesn't show you standard deviation because what we forgot to do, we have to take a square root of it, right? This is just a total sum. It's just this value divided by n. Yes, it's we program the formula under square root. So maybe you know what? Let's set up straight away here. So just in case you don't remember, SQRT. It's a square root of the value. All right, 0.05, it's our standard deviation. Once again, let maybe talk a little bit through what this value means. So I will use now a histogram. It's nice representation because we don't work with ungroup data. We know with you that our mean is 3.51. So our mean just about here, 3.52. It represents this value, so 3 point here. This is our mean. Now, if you calculate mean plus 3 sigma, so equal to mean plus 3 times this value of standard deviation. What we got? We got 34.68. Where is that? This is midpoint, and 62, so 68 will be somewhere there. So mean plus 3 sigmas give us right hand side of the corridor where our data spreaded. And mean minus 3 sigmas. Just let's do it. Mean minus 3 times sigma, this sigma, 3.34. So this is our left corridor. So we can guarantee that not 900%. Let me go back to this PowerPoint and go through this 6-rule presentation. Calculation on sigma says that this mean plus 3 sigmas and mean minus 3 sigma in this corridor, not 100%, but 99.7% data will be in this corridor. The rest data, they call them outliers in statistics. 1 sigma, mean plus 1 plus minus 1 sigma give us the corridor for 68% of data, and plus minus 2 sigmas, 95%, they call it confidence interval. So 95% data will be in the corridor mean plus minus 2 sigma. So we can guarantee it that 99% data in our samples will be in confidence interval mean plus or minus 2 sigmas, and 68% data mean plus minus 1 sigma. So this graph people use to calculate probabilities of what's happened with our data. Okay, hopefully I told everything about how to calculate mean and standard deviation for group data. And most important, you have to understand what standard deviation means, because this is a new thing in your math